In this problem, we have a gear A that is being turned by a motor with a constant angular acceleration of 4.5 radian per second squared. Gear A starts from rest, and gear A actually turns this gear B that is connected to it, and on gear B there's a pulley that is fixed to it, and on the pulley there wraps a cable which is connected to a cylinder, and we need to determine the linear velocity of the cylinder as well as the distance it has traveled in 3 seconds. So we can tell that the linear velocity of the cylinder will always be the same as the linear velocity of point P prime on the pulley. Therefore, Vc will always equals to Vp prime, which equals to omega B, because pulley D turns with the gear B, times Rd, which is this distance right here. And if we know the tangential acceleration AP prime here, which actually you can tell that it's going to be a constant value as well, we can show that later, then we can determine the displacement of SP prime from the kinematic equations with constant acceleration that equals to S0, let's just call it 0, plus initial velocity is 0 because the system starts from rest. So 0 plus 0 plus 1/2 constant acceleration AP prime times t squared. So that's the plan. That's how we're going to solve this problem. So how do we find AP prime then? AP prime being the tangential acceleration of point P prime, and it equals to alpha B, which is the angular acceleration of the gear B, times Rd. So that's the plan, but we are only given the angular acceleration of gear A. However, notice that point P is the point of contact between gear A and gear B. Therefore, the linear velocity of point P is always the same, and it can be determined either from gear A as omega A times Ra, or it can be determined from gear B, which is omega B times Rb. Therefore, from here you can tell that omega B equals to omega A times Rb, Ra over Rb. And you can write the same relation for the tangential component of the acceleration at point P. This tangential component AP, let me call it ATP for tangential. Over here it's the same. This is ATP prime. This equals to alpha A times Ra evaluated from gear A, but at the same time it's the same as alpha B Rb evaluated from gear B. Therefore, from here we can determine that alpha B also equals to alpha A times Ra over Rb. So now we know that alpha A is a constant 4.5 radian per second squared. Therefore, from here, using different colors so it's clearer, alpha B equals to 4.5 times 75 millimeter over 225 millimeter. That's the ratio of the radius of gear A versus gear B. Therefore, alpha B is also a constant 1.5 radian per second squared. So this is a constant. So if it's a constant, we can also apply the kinematic equations for theta, omega, and alpha. When alpha is a constant, omega B also equals to alpha b times t. It is actually omega 0 plus alpha b times t, but initially the system is at rest, therefore it's simply alpha b times t, and that equals to 1.5 times t equals to 3, and that is 4.5 radian per second. Now this is not a constant. This is evaluated at t equals to 3 seconds. But with omega b, we can calculate Vp prime actually. Vp prime equals to omega b times Rd. Therefore, that is 4.5 times 125 millimeters. Therefore, that's 0.125 meter, which equals to 0.5625 or 0.563 if we take 3 significant figures in the unit of meter per second. Again, that is at t equals to 3 seconds. It's not a constant. And then going back to this equation, because AP prime equals to alpha b times Rd, so ATP prime equals to alpha b, that is 1.5 times Rd, 0.125 meter, and that equals to 0.1875 meter per second squared. And then substituted into this equation, SP prime, the displacement equals to 1/2 ATP prime times t squared, which is 1/2 times 0.1875 times 3 squared, and that equals to 0.844 meter. So this is linear velocity of cylinder C at a time equals to 3 seconds after it has traveled for 3 seconds. And this is the displacement of the cylinder C, again, after it has traveled for 3 seconds. So again, to solve this problem, it's important to recognize that the point of contact between two gears will always have the same linear velocity, and it will always have the same tangential acceleration.